Hello guys, welcome. Today we will see system design for a movie booking system, and let's discuss this. So, let's say uh, somebody is asking to design us to book the movies. How we can how that will work at very high level. Okay, so let's say n number of users are there. So let's say these are the users. Let me pick different pane. Okay, these are the users and they want to book movies. Okay, so first API gateway layer, it will hit whatever the request are getting sent, those will come to API gateway layer. At API gateway layer we will handle authorization, authentication and rate limit, and then our request will be get transferred to the main microservice layer. So in microservice layer, let's say there are n number of microservice. Ticket booking microservice is there, then this payment microservice is there, and then this the user microservice is there, this is inventory microservice is there, and then this is notification microservice is there. All these microservices can have n number of replicas. Let's say 5 or 10 replicas are there to get high availability. Okay, and for all the microservices we can have add load balancing for each microservice, so that the load can be transferred to the different services as per the load. Then in between we can add this kind of queue also, so that let's say ticket booking microservice is sending some event, then we can say uh, our event is sent to ticket booking service, so that ticket booking is initiated. Then this inventory service is there, it will read that event, a ticket booking initiated event, and will check in inventory how many tickets are available for booking. Okay, like that. So it can be achieved using the messaging queue, any Kafka related or any messaging queue, IBM IQ, anything we can use. Okay, then we can have n number of DBs for that. So these are the we can use for this relational DB, like post GRE DB for payment, storing the payment related info, user related info, authentication related info. We can use the relational database, and we can use NoSQL database. Okay, non-relational database for storing the uh, frequently asked things like map of the ticket, then how many tickets are available currently, then all those things we can store in uh, NoSQL databases. Okay, so and also in between we can add Redis cache or meme cache, something like this, to and in that cache we can store frequently asked information, like movie booking system is ready heavy, it is heavy read only system, right? So in that cache we can add seat availability, pricing, offers, frequently accessed metadata like theater details, screen info, all these details we can add to this kind of cache. So this is very high level design for a movie ticket booking system. And if we check the steps, then users are there. They try to book the ticket using any web app or mobile app. There are n number of users who will try to book the ticket. Then each request will go to API gateway. Here at API gateway, we will handle security related and authorization and authentication. Then rate limiting also we can add in gateway layer itself. Then there are different kind of microservices like ticket booking microservice, payment service, user service, notification service, seat availability service, auth service. All these kind of services are there. Each service can have its own load balancer to handle the load. Also there will be a messaging queue. Each service will send the notification. For example, uh, movie ticket booking service is there, it is sending ticket booking initiated notification, and then consumers like inventory service will read that notification and we'll check whether in inventory any tickets are available or not. Then we will have different kind of DBs like SQL DB or no SQL DB as per our requirement. For example, we are using post GRE SQL. to avoid the duplicate bookings, to handle the locking, for saving payment transactions. So it is very secure, so we can use PostgreDB. And we will use MongoDB, where read operations are more like seat layout. For booking history, suppose we want to show entire seat map, we want to show all those requirements, we can use MongoDB. And also we can in DB layer we can add cache, so Redis cache or mem cache, to reduce the latency. Okay, so before hitting the DB, it will check in cache itself, and we can set some timeout for those cached values, so that n number of cached values will not store longer there. Okay, so why we add the cache? Because movie booking system is the read only and heavy reading system, right? So frequently we want to get the availability of the seats, right? So we can use the cache to get the fast response, so that we can use the cache, and we can store in cache. We can store movies, seat availability, pricing, offers, frequently accessed metadata like theater details, screen info, all these details we can store inside the cache. Okay, so this is very high level design of movie ticket booking system. There can be added there n number of other details also, but for learning purpose, this is the very basic one. Okay, thank you.